Welcome to question number 2 from the 2023 AP Statistics FRQ exam. In this video, we're going to take a look at the question and fully explain the answers as best as I can. All right, let's dive right into it. So here was the problem. A developer wants to know whether adding fibers to concrete used in paving driveways will reduce the severity of cracking because any driveway with severe cracks will have to be repaired by the developer. The developer conducts a completely randomized experiment with 60 new homes that need driveways. 30 of the drives will be randomly assigned to receive concrete that contains fibers, and the other 30 receive concrete that does not contain fibers. After 1 year, the developer records the severity of cracks in each driveway on a scale from 0 to 10, with 0 representing not cracked at all and 10 representing severely cracked. First question, question A. Based on the information provided about the developer's experiment, identify each of the following: the experimental units, the treatments, and the response variable. Pretty easy question here, so let's make sure we give a lot of detail. But again, there's not a ton of detail to give, but again, always talk about context. So the experimental units are actually the 60 driveways from the 60 new homes that needed driveways. So be very clear on that. A lot of kids will say the concrete. No, the concrete is actually not the experimental units. It's the 60 homes. Those are the experimental units that all needed driveways, and every one of those homes is getting a driveway. So really we have 60 driveways. All right, now the treatments for the driveways are concrete that contains fibers and concrete that does not contain fibers. Pretty easy, but be specific. The response variable is what we're measuring at the end. Again, be specific here. The response variable will be the severity of the cracks in each driveway after 1 year, measured on a scale of 0 to 10, 0 being no cracks and 10 being severely cracked. Listen, copy from the problem. Why waste your time trying to make up an answer or trying to shortcut an answer because you just want to rush through it? Literally copy the words from the problem. So pretty easy, part A. Part B says, describe an appropriate method the developer could use to randomly assign concrete that contains fibers and concrete that does not contain fibers to the 60 driveways. Keep this simple. Each of the 60 new homes would receive a number 0, 1 through 60. Using a random number generator or a random number table if you want. Ignore repeats, ignore numbers no house has. The 30 numbers will be selected randomly, and those corresponding houses will receive driveways with concrete that contains the fibers, while the remaining 30 homes will receive driveways with concrete that does not contain fibers. So again, very simple, using a random number generator, making sure to ignore repeats, can't have one house getting both treatments, that doesn't make sense. And also numbers that no house has, a random generator could produce 74, but no house has that. And again, the first 30 that were randomly selected using that random number generator will receive the concrete that contains fibers, and that automatically means that the 30 houses that remain will receive the concrete that does not contain fibers. Now I also added here, don't necessarily know if this is necessary because it doesn't really focus on what the question says, but I thought it was also important to say homeowners and installers as well as the evaluators will not be told which driveway had the fibers and which didn't. The head researcher knows, the head developer, the guy who's running this whole thing is going to know what 30 have the fibers and what 30 don't. But the homeowners should not know because we don't want them to treat their driveway differently one way or the other. The evaluators should not know that we don't want them to think one way or the other and be biased. And again, that's double blinding. Not necessarily part of the actual explanation of the random assignment, but I thought it was important to note that. All right, one more question here from this problem. Suppose the developer finds that there is statistically significant reduction in the mean severity of cracks in driveway using the concrete that contains fibers compared to the driveways using concrete that does not contain fibers. So at the end of this, maybe they find out that the 30 homes that did have the fibers, or the 30 driveways that did have the fibers in the concrete, were way less cracked than the others. So in terms of the developer's conclusion, what is the benefit of randomly assigning the driveways to either the concrete that contains fibers or the concrete that does not? So this actually is focusing on why we have random assignment, why random assignment is one of the 4 pillars of an experiment. So keep in mind that anytime we have treatment groups, in this case 2, we want those 2 groups to be as identical as possible. We want them to be very, very, very similar. We want group A and group B to be identical to themselves. That way the only difference is did they get the concrete with fiber or without. Now, we could use lots of other things. We could do match pair, we could do blocking to all help that. And go back to the previous question about the random assignment. I mean, maybe you did come up with a block pair or a match pair. I mean, that could be done. I was just trying to keep it simple. But here they're focusing on, why is that random assignment so important? Again, random assignment is going to help really ensure that other extraneous variables are evenly dispersed between the two treatment groups. So here's the deal. Random assignment will ensure that the two treatment groups are as similar as possible except for the driveways that have concrete with fibers and those that did not. So here are some other variables that could impact the severity of cracks in the driveway. The size of the driveway, maybe bigger driveways have a tendency to crack more. The weight of the vehicles on the driveway, if you put dump trucks and other big construction vehicles or big SUVs, it could cause them to crack. Just use, if some driveways get used more or maybe hit with a plow during the wintertime. Winter temperatures, if some of these houses are south and some of these houses are north, the temperatures could affect it. The soil in the ground, not group, I should say ground, the soil in the ground underneath the driveways could impact it, like if it's firmly put down versus loose soil or different clay types of soil or sandy soil. I mean, all of those things play a part. Now, maybe they could have been smart and did a matched pair design or some type of blocking design on one of these variables that they thought was really important. But listen, this is where having random assignment will help. It'll help evenly disperse these other variables into both groups. So if it's truly random, we should have some driveways that are heavy used in both groups, some driveways that have heavy vehicles on them in both groups, driveways that are in colder temperatures in both groups, warmer temperatures in both groups, good soil in both groups, bad soil in both groups. That way we truly have these two treatment groups that are identical as possible for fair comparison that allows us to actually get these statistically significant results. Now, if you're like, oh my gosh, I didn't even think about soil under the driveway, that is so important, well then maybe you block or maybe you use all the same soil, guaranteeing that it's kept the same for everything. But there are only so many things that we can actually control for in an experiment. Sometimes if you control too much, you actually ruin your experiment. So the idea here is that random assignment helps evenly disperse all of those other extraneous variables into both groups. At the end of the day, I have two groups that are as similar as humanly possible other than the treatments I give them. All right, that's it for question number 2. I thought it was a pretty easy one overall. If you understood the big ideas, hopefully you did a good job on it.